Welcome to the Digital Design and Computer Organization BCS302 Laboratory Sessions. This is Razika Amrin, Assistant Professor from Computer Science Cybersecurity, ATME, Mysuru. So today we are going to take up the experiment number 4.B, that is a half subtractor. So the aim of the experiment is to design a Verilog HDL code to implement the binary subtractor half and full subtractors. So here is the logic diagram in order to perform the half subtractor. So A and B are the inputs. Here analyzing what is the outcome or the output is more important, wherein since A, B are the inputs, the expected output from the half subtractor will be the difference and the borrow. This is the logic diagram of the logic symbol is represented, and this represents the logic diagram wherein A and B are the inputs provided and connected to difference and borrow as the output obtained. So the logic diagram represents the difference, which is represented with the XOR gate, because the logic of performing the difference, that is 1 minus 0 will be 1 or 0 minus 1 will be 1. So since the different obeys the logic of the XOR gate, we are using the XOR gate to provide the input, and the borrow is representing the NOT, because the NOT of 0 minus 1, it is not possible to perform 0 minus 1. So in order to perform the subtraction, we take 1 as a borrow to this, which in turns become 1 0. 1 0 is the binary representation of digital number 2. So this 2 is considered 2 minus 1 will get you the difference as 1. So that is why this logic assign borrow as not of B and not of A and B. So you will obtain the borrow. The only difference you need to make out here is 0 minus 1. When this scenario comes in order to perform the binary differences or the subtraction, the borrow will be 1 and the difference will be 1 as well. In other case, if either of the 1, the difference is 1, else in other cases the output will be 0. So this is module is the keyword, end module is another keyword, half subtractor is the name. In order to write the Verilog code or Verilog HDL implementation of the subtraction, input A and B and output is considered as difference and borrow, assigning the logic for difference as A XOR of B and assigning the borrow as negation of A and B and in the module. So this is the data flow description for the half subtractor performed. So when you go into the ISE design suite, here I have written the module, the code that has to be represented and implementing the design. Once the implementation is done and the synthesis is done, you will obtain with the green tick mark here. So once it's done, we'll pause on to the simulation part, when in the simulation also will be taken care. So simulation performs with respect to displaying the waveforms with respect to zeros and ones, high if it is 1, low if it is 0. So since I have got this green tick, it's taken up with this thing. Moving on to the txt file, in order to run this suit, I have provided the input values with the time delay as 100 and A as 0001 or 0101 likewise. So when I simulate it using the simulator, I will obtain the output in the form wherein you could see the input values. When all the inputs are 0, the difference and borrow will remain 0, and this waveform is for when A is equal to 0 and B is equal to 1. In this case, the borrow and the difference both will be high, as I mentioned you. And in this case, if you see, if A and B are equal to 1, then the output or the difference will remain low, that is 0. So likewise for the other cases and vice versa. Thank you.